Welcome to The Explainer. Look, a basic LogQL query is fine for just finding log lines, but if you really want to extract meaning from them, you need a LogQL pipeline. Today, we're tackling a real-world troubleshooting mystery, stepping into a dark-themed Grafana Explore environment to build a pipeline completely from scratch, step by step. So let's jump right in. Picture this scenario. An engineer strongly suspects there was a brief, massive spike in 500 errors on the payment service. Customers were absolutely complaining, right? But when we go to check our standard Prometheus metrics, which are set up with that standard 1-minute scrape resolution, they show absolutely nothing. Zero. The outage was so fast that it slipped perfectly between the metric scrapes. It's one of those incredibly frustrating ghost anomalies. Okay, so let's start digging into this by laying down our foundation. We'll use the most basic stream selector. Job equals payments. This just fetches our raw, unfiltered log stream. We're essentially pointing Loki directly at the problem area, pulling in every single log line that the payment service is spitting out. Now, right off the bat, these logs are just a messy wall of text. It's a massive, nested JSON payload, and we all know how painfully slow that is for a human to scan. I mean, staring at raw JSON when production is literally on fire is nobody's idea of a good time. But if we pass this stream through a simple JSON parser in our pipeline, watch what happens. Those buried key value fields are cleanly extracted and suddenly they just leap right out at you. The way Loki actually pulls this off is through a brilliant little concept called schema at query. Traditional databases force you to parse and index every single field before you even save it, which, let's be honest, costs an absolute fortune in storage. But Loki, it extracts that structured data into temporary, fully queryable labels at the exact moment you hit search. It's a real game changer. So, opening up the label browser panel in our Grafana Play demo environment, the results are instantly there. Our parser has magically turned those nested JSON keys into ready-to-use labels. We can now interact directly with things like status code, method, duration, and the request URI. We're treating them exactly as if they were indexed metadata. And because we have these newly extracted labels, we can instantly filter out all that background noise. We take our parsed stream and simply append a new condition, status code greater than or equal to 500. Just like that, we're strictly isolating the exact log lines where the server threw an error, cutting right through millions of successful, boring transactions. Now we want to make that isolated data actually readable for the team. By throwing line format and label format expressions into the mix, we can completely strip away that noisy, repetitive JSON structure. We're swapping out a genuinely ugly, raw JSON string for a clean, perfectly readable summary line. Much better. So the absolutely crucial takeaway here is that we've progressively built up a highly efficient pipeline. Think about it. We select the stream, we extract the labels, filter down to the exact errors we care about, and format the final output using a simple template string. And we did the whole shebang without ever leaving the query builder. It's a total transformation of our raw data. But wait, here is the catch. At this point, we still just have a scrolling list of formatted text. If you're trying to show leadership or your engineering team exactly what went wrong, a scrolling wall of text doesn't actually give us the overall error rate over time. It doesn't definitively prove the spike happened. To finally solve this mystery, we need to unlock LogQL's true superpower, converting a log stream directly into a metric query. We're going to calculate mathematical values based strictly on our log results. We are effectively treating our raw log streams as a direct source of rate data, which lets us generate actual graphs and alerts. Let's do a quick review of the logic for this conversion. First, select the stream. Second, parse that JSON. Third, filter for the 500s. And then the final, absolute magic step, we wrap that entire pipeline in a rate function. We're leveling up from looking at individual lines of text to graphing the mathematical rate of those lines over time. By executing that rate function over a 15-second moving window, we find the absolute key to our whole investigation. Specifying that tiny 15-second bracket lets us completely bypass the 1-minute limitation of our standard Prometheus metrics. It hands us the high-resolution data we desperately needed all along. Switching our view from logs over to metrics, the truth is finally exposed. The graph clearly, undeniably reveals that hidden 30-second error spike that Prometheus entirely missed. The whole outage happened precisely between those standard 60-second scrapes, but by turning our logs into high-resolution metrics, we caught it red-handed. Ultimately, you have to realize Loki isn't just some basic log search or a simple grep replacement. This whole success story really highlights how extracting labels at query time and then turning those logs into metrics empowers you to catch those nasty micro outages and silent failures that traditional tools just completely overlook. To wrap up this explainer, I really want you to think about your own environments for a second. Ask yourself, what critical events are hiding right now in your raw logs, just waiting for the right LogQL pipeline to uncover them? Mastering these techniques might literally be the key to solving your very next operational mystery.